Hello and welcome to the PMOD introductory series. In this short video, we will provide a brief overview of pipeline processing in PMOD. The PMOD modules are highly rated tools for interactive image analysis and kinetic modeling. However, automated data processing is preferable for objective and reproducible processing of data from large studies. Therefore, PMOD has created a new interface for leveraging its existing and proven functionality into data processing pipelines. In practice, the analysis methodology is first interactively prototyped. It is then converted into a sequence of automatic processing steps and tested using breakpoints on a subset of the data. Finally, the whole dataset is submitted for processing. Quality control elements allow the ongoing data analysis to be monitored, and intermediate results can be saved for post-hoc investigations. The main outcomes, such as regional tracer uptake or kinetic parameters, are directly pooled into population aggregates, ready for population statistics. The pipeline processing solution will be briefly presented in the following demo. This pipeline example processes data from a neurological study. For each patient, a dynamic C11-PIB PET acquisition was acquired to quantify the amyloid load in the cerebral cortex. A T1-weighted MRI was additionally acquired as a reference for the brain anatomy. The analysis sequence first derives outlines of 83 brain areas from the MRI using the Hammer's Maximum Probability Atlas. Next, the MRI is richly matched to the PET so that the brain areas can be projected onto the PET images. The tracer uptake is then averaged per brain area and analyzed using the simplified reference tissue model. Finally, the resulting binding potentials from all subjects are pooled in an overall aggregate. This data structure is ready for population statistics using PMOD's streamlined R interface. In the PMOD pipeline interface, the processing sequence is first defined. As the first step, a standard set of brain areas are defined based on the patient's MR images. The corresponding automatic brain VOIs tool is therefore added, which incorporates a part of PMOD's fusion methodology. It is configured to use Hammer's Maximum Probability Atlas with MRI-based stereotactic normalization. A quality control element is then added to verify the outcome interactively or save a representative screen capture. As a next step, the registration tool is added to rigidly match the MR and the PET. Then, the PET images are loaded into the pipeline sequence with the Replace Images tool. Finally, the kinetic modeling interface is added. The rigid transformation between the MR and the PET is applied to map the individual brain areas to the original PET images. The simplified reference tissue model is applied to calculate the regional binding potential using the cerebellum as reference region. After defining the processing pipeline, the list of input data is created. A convenient previewing option allows the performance for the selected dataset to be tested. For example, the brain areas generated can be inspected in overlay on the patient MR images and after projection to the PET images. Similarly, the fitted kinetic models can be validated within the modeling interface. After positive evaluation, the overall processing is started and runs in the background. Intermediate results, such as the area outlines, transformations, and the modeling files, are optionally stored. An aggregation procedure collects the main outcomes for the whole population. In the current example, the regional binding potential for all subjects is assembled in a large table, ready for population statistics. In summary, pipeline processing supports the automated analysis of study data, leveraging the functionality of several interactive PMOD tools. Trial installations are available to test the full functionality of PMOD and its tools. Please visit our website to learn more about this and the other products from PMOD Technologies. Thank you for your attention.